Okay, welcome back. This is Mr. Hassan's Maths channel, and I'm now going to answer question number 10 from the International A-Level Edexcel Pure Mathematics P4 October 2022 exam. This question here is about, I think, differential equations. It says a spherical ball of ice of radius 12 centimeters is placed in a bucket of water. In a model of the situation, the ball remains spherical as it melts. T minutes after the ball of ice is placed in the bucket, the radius is r centimeters. So r is in centimeters, t is in minutes. The rate of decrease of the radius of the ball of ice is inversely proportional to the square of the radius. So we can say here from this that dr dt is equal to minus k times, or k divided by r squared. It's a decrease, so it's going down. So you have minus k over r squared. All right, it's inversely proportional, so it's k divided by the square of the radius, r squared. So that's the rate of change of the radius is inversely proportional to the square of the radius. Of course, the radius of the ball is going to decrease as it melts. The radius of the ball of ice is 6 centimeters after 15 minutes. So we can say when t equals 15, r will be 6. And from here we can say that when t equals 0, r equals 12. It starts off at 12 centimeters. All right. So this is the information that we can derive from this particular. We can derive these pieces of information. So I'll put these over here. Okay, and that might help us to. So it says using the model and the information given, find an equation linking r and t. So I've got to end up with r equals some function of t, something of that sort. I've got to basically solve this differential equation. I've got to get rid of the dr dt and write it as in terms of r, okay, and have to have t in there. So we got to solve the differential equation dr dt equals minus k over r squared. So for us to solve this, what I'm going to do is I'm going to integrate both sides with respect to t. So I have dr dt integrated with respect to t equals, and I'll have minus k, and then I'll have integral of 1 over r squared integrated with respect to t. I've just wrote the constant outside. I always like to do that. Now these will cancel out, and I can now write this. I can separate the variables. So the r's will go in the side of the dr. So this will say r squared with respect to r equals, and the t's will be on the side of t. Now there's no t term, so there's just a 1 there. So you got minus k. I like to, as I said, write the outside, and this is going to be 1 with respect to t. Now what we can do is we can use some of the information that we have been given. So for example, I want to find what k is. I can use these bits of information. I know when r is 12, t is 0, and when r is 6, t is 15. Okay, so if I use those limits, that will help me find what k is. Okay, that will help me find what k is. I can use those limits to do that. So if I integrate both sides now with respect to wherever they're supposed to be integrated to, this side is going to say r cubed over 3. And I have the limits 12 and 6 to put in here, equals minus k times, and here I'll have t, because this is 1 with respect to t, integrate to give you t, and I have 0 and 15. So substituting those values, I'll have basically 12 cubed minus 6 cubed over 3 equals minus k times 0 minus 15. Okay, so let's work out what this is. I have 12 cubed minus 6 cubed over 3. That gives me 504 equals minus k times minus 15. So we're going to divide both sides by 15 basically. So k is going to be 504 over 15. Okay, 504 over 15. That gives me 168 over 5. So therefore k is 168 over 5. 168 over 5. We can write that as a decimal if you want to. That gives me 33.6. So K is equal to 33.6. So I found the value of K, and now I need to have an expression of R in terms of T. So I can go back to this, what we've integrated already. And I know K now is 33.6. I have T. Now I can use, I want to find what R is in terms of T, and I can use the value again of 6 and 15, and that will give me my answer without having to put plus C. It will tell me what C is. So this is going to be R cubed minus 6 cubed over 3 equals minus 33.6 times T minus 15. Okay, so you have R cubed minus 6 cubed. So what's 6 cubed? 216, I think that is. So R cubed minus 216 over 3 equals minus 33.6 T plus this times 15, 504. So we can say R cubed minus 216 equals, if you multiply this by 3, that gives you 1,512. And you multiply this by 3. Okay. Sorry, what we're doing, that's 33.6 multiplied by 3 gives me 504 over 5, which is 100.8. So this minus 100.8 T plus 512, and now I've got to add 216 to both sides. So R cubed equals minus 100.8 T, and that's plus 1,512. I'm going to add to that 216. That gives me 1,728. So there's my equation which links R and T together. Okay, just make that decimal point a bit clearer there. Minus 0.8 T. Okay, so there's our equation linking R and T together using differential equations. So we have solved that. Now I could have integrated this here and used plus C, and then, you know, I could have had an expression with K and plus C in there, and then substituted R as 12 and T as 0 to find what K is, and then substituted R as 6 and T as 15 to find what C is, and then wrote my answer. But I like to use these limits in this way to find the answers without having to put plus C. That's just what I like to do. I find it makes life a lot easier than writing plus C's, especially in certain types of questions. It makes it really easy. So that's why I stick to this way. Both of them are basically the same thing. This kind of automatically finds the value of C for you. That's what happens here. All right, so now we're going to answer part B of this question. All right, so it says, find the time taken for the ball of ice to melt completely. All right, when the ice melts completely, the radius is going to be 0. And that's what we've got to find the time for. So that's pretty simple. We've just got to replace R with 0. That gives you 0 equals minus 100.8 times T plus 1,728. So you simply have to divide 1,728 by 100.8. Okay, you're going to add this to both sides to become positive, then divide both sides by 100.8. So therefore T is equal to, so we take this value and divide it by 100.8, and that gives you 120 over 7, which is 17.142. 17.1428 continues on. So we can say therefore the time is 17.1. Okay, so it takes, we can say it takes 17.1 minutes to melt completely. So it becomes nothing. All right, so there's the answer for part B of question number 10. Now for part C, they've given us a sketch. All right, so we found that K is equal to, what was that as a decimal? K was 33.6 as a decimal. All right, so you ended up with this being basically minus 33.6. So you ended up with dr dt, if you think of it as minus 33.6 over r squared. Okay, that's dr dt. That was not our equation. That was you could say the rate of change of r with respect to t. K was 33.6, so we end up with minus 33.6 over r squared. So it says we got to make a sketch of r against t. So we know that when t is equal to, it was 17.1 minutes, r is 0. So it goes from here to there, right? So it starts off as a radius of 12, ends up with a radius of 0, and it takes 17.1 seconds. So these are going to be connected, but how are they connected? Well, we know that this tells us about the gradient of the curve. This is the rate of change of r with respect to t. So this tells us what happens to the gradient as the radius increases. Now, as you can see, as the radius gets bigger and bigger of this, okay, then when the radius increases, okay, then the rate of change of the gradient, okay, its magnitude is going to get bigger and bigger. Okay. Yeah, so as the radius decreases, okay, this is going to get, its magnitude is going to get bigger. For example, when r is a half, okay, this will be multiplied by 4. When r is 1/8, it's going to be multiplied by 64, and so on. So the magnitude of the gradient is going to get bigger. It's going to get more steep, but in the negative direction. It's going to be going, it's going to start off like this. It's going to get more and more steep as time goes on. So this is going to be some curve that looks something like this. It's going to look something like this, because the gradient of this, as r increases, then dr dt, okay, so as r decreases, because the radius is getting less, you can say as r decreases, dr dt, its magnitude is going to increase. Okay, it's going to get more and more steep. You can see as r gets less, the magnitude of the gradient is going to get more, because they're inversely proportional. Okay, so as this denominator gets less and less, this is going to get more and more, right? So in terms of its magnitude, okay, in terms of its magnitude. But because it's negative, it's going to get more and more negative. Okay, it's going to get more and more negative. So the graph is going to be steeper and steeper as you go along. Okay, so the gradient is going to start off, you know, shallow, and as r gets less and less, the magnitude of the gradient is going to get more and more, so it's going to become more and more negative. So it's going to have this kind of curved shape where the gradient is, its magnitude is increasing. You can say the gradient is decreasing, like, you know, its magnitude is getting more and more steep. Okay, so that's how we can understand how this graph should look. I hope that was clear there. All right, you have to think a little bit about it, and thinking about this relationship between them will help us to think about how the shape of the graph is, because the shape of the graph is determined by its gradient, right? So this tells us about the gradient of r with respect to t. That's what this is. All right, so we can see that, you know, as r gets less, which is what's happening, the steepness of this curve is going to become more, but in a negative direction. All right, so that's how we draw the curve, and that's the answer to this question, question number 10. Other questions from this particular paper can be found in the playlist that will appear over here. Other questions from this topic of differential equations can be found in the playlist in this area over here. You can subscribe to my channel by clicking on the link, and you can watch the video that will appear in this link over here for you to see how to use my channel to help you with your revision and find things that you might need quickly. Thank you for watching, and see you soon.